So do you know the sketch? I'll give you maybe 1 to 2 minutes just to sketch the free body diagram, and then I'll do it with you guys at the same time. It should be very straightforward, not really that something very complicated. So the first point, we call it point A. A second point, we call it point B, as you can see here. In my free body diagram, I need always to show my dimensions. It's very important because otherwise, if I'm taking a moment around the points, I may miss the point, and that's why we need to make sure we have the dimensions specified correctly. That's one of the common mistakes could be seen when we're marking the quiz or test. So let's say here this one is 4 meters, and the other one is 2 meters. All good. Just checking all of you there. And the value for that force is 9 kilonewtons. It's very straightforward. By experience, by the end of this course, you would do this straightforward. You don't really need to spend more time to solve this kind of examples. I would just get this equation from here because I need it, so I can solve this example. So algebraic summation of forces in the y or vertical axis is equal to 0. So let's write the equation. It's a very general equation. What do you have? I will call A plus B. So what's A? This support reaction A, support reaction B is equal all the forces going downwards, which is the 9 kilonewton. I will call this equation 1. Why? Because I have two unknowns, A and B. By the way, you can call it force A, force B, it's up to you. So nothing, any name, but I'm just referring them based on the points A and B. Again, the question should has another force in that direction. So it's going there because it's fixed. So it should be AX and AY, but because there is no force in the X direction, so that force will be always equal to 0. And when I'm trying to solve this, I need always to specify that summation of forces going up, it's the positive direction. So I put an arrow next to that sign to represent for me. So definitely I need to find another equation to find one of these values, A or B. So because I have the equations set up here, just copy the equation so I can use it straightforward instead of using the editor. And then as well, I will assume the clockwise is the positive. So I'm taking the moment around point A. So let's write this equation. What should be? So B will be rotating, which direction? Will be rotating against the clockwise or anti-clockwise. So that will be minus B value times what's the distance from here to that point is 6, 2 plus 4. So I'll write 4 plus 2, which is equal to 6. And then I have this 9 kilonewtons, the other force will be rotating clockwise. So plus 9 is the amount of the force times 4, which is the distance. So from this force to that point is about 4 meters. Anything else? No, because at that point there is a support reactions. Both of them, they actually pass through point A, so I don't need to take them into account. Is equal to 0. Rearranging this equation, B is equals, so I will just make sure you can get it. B is equals to 9 times 4, all of that divided by 6. And that will give you the value. So very straightforward. So if we revise this step, it's very straightforward. We use it for all these solutions, but you really need to be careful to find the right answer for the support reactions, because if we got the support reactions wrong, then technically everything will be wrong in your shear force and bending moment diagrams. So we make sure that what we got here is correct. So is that correct? The value for 6 kilonewtons, I will see it, and then check it. If it's something wrong, just let me know. Now, using equation 1, we can find from it that A plus 6 is equal to 9. Then by rearranging, A is equal, forgot to put the 6, A is equal to what? 9 minus 6, and therefore the value for A is equal to 3 kilonewtons. So when we found those values, we just came to this diagram here and we write the value for A is 3 kilonewtons. And then the value for B is 6 kilonewtons. Very straightforward. So it's to sum up what we learned from non-concurrent forces. We're applying summation of forces in the vertical direction, y-axis, and taking a moment about one of the points so we can find the other value, and then we go through it. So since we have all the support reaction forces values and as well the external one, which is 9 kilonewtons, we need to sketch the shear force diagram. So what we do in this situation, you need to project a disconnected line from every effect or impact or a point where the force is applied. And I will call it shear force. And the unit for it is kilonewton. So when I write the numbers, I don't need to repeat the units. This is the 0 point, reference point. So I'm starting from it, I'll go upwards. So from here, if you do it to scale, will be, if we are very precise, should be the value of 3. So let's do it something reasonably acceptable. So that's 3. And then nothing happened from this point till the action of the 9. So that's all of it is a 3. Don't need to write the units because I'm specified in my graph, that's the units. It's kilonewtons. And then 3, I need to move with the 9. So 3 minus 9, I will have a line is going downwards with a value of, we'll stop till here, and that will be, I'll write the equation for you guys, 3 minus 9, which is equal to minus 6, the value for that point. And that will represent for me where is the shear force acting. Now 6, there is no effect of any external forces from this point till we reach to that point, and there is a support reactions equals to 6, which will take me back to 0. And then we close this shear force diagram. So I'll go through your chat. We have a couple of chat things which I'm trying to read, 4 things to display. So Mohammed, should I record if I want to view it again? Yes, you can record, but I'm already recording it, so I'm playing the record technically. Hopefully the record will start, will be saved. And there is another Min, Sean, to everyone. I'm watching it now. Okay, Min, thank you. You're watching, that sounds good. And there is iPhone to everyone. Sleepy Pro, who's that guy? I don't know. And Oily, yes, I can hear you. It was me. Can't remove it. It's okay. It's all good. Now I figure out how to fix it. Caleb, hello, everyone. Bob is okay. Hello, Michael. Good. So I think if you have any things, I will stop and trying to go through your comments every time we take a break. So if you have something, just put on the comment. I will go through it. All right. So as soon as we finish this, now the new way to determine the bending moment diagram, so right here in this point, bending moment, just the first letters, and the unit is kilonewtons times meters. So it's force multiplied by distance. I just put this here, so I don't need to worry about writing dimensions in the diagram. So the way we learn it is to work by area. So right here, from the shear force, write the area for this one. So what's the area for this one? You have height is equal to 3 times distance. Distance from here to this point is about 4 meters. And that will be equal to, if you try to calculate it, is 12. Therefore, as we said before, to convert a rectangular or straight line, we need to convert it to a slope. Because it's a positive area, therefore this one will be going upwards in that point. So that's represent for me the point of 12 kilonewtons. Again, I don't need to write the units because it's already specified in my diagram here. Now we need to determine the area for the other rectangular. This area is equal. Let's write the area. So at least when you revise, you know what we're doing. This dimension is 6. And remember, it's negative, but the area is fine. Times this length is 2 meters. We get it from this dimension. Times 2 will be equals to 12. But this is negative. So we have a positive area here, and here we have a negative. So positive here, and here is negative. Therefore, from 12, I need to go to 0, and that means it's closing my diagram. So that's how it looks like the bending moment diagram for this question. Very easy, simple steps. It doesn't really require a lot of work because it simply is very simple example. So if you have a comments, we'll go through them now. If you want to chat or ask any question, please feel free to ask now, so I can go through them. Other than that, I'll give you a few minutes to go through this, and then we start another example. Yes, we'll do it easy peasy. I like it. So since it's easy, the second one, I think it's slightly easy one, but will be for cantilever. So if all you guys okay, just let me know so I can move to the second question. Just point like this if you're good. Or if you have any question, ask so I can go through it now. The good news, we have about 25 students watching this, including myself. So that sounds really awesome. Sounds really good. So Min, I can see Min here. Please, if you have any comments, type on the chat so I can really go through it if you have any questions. So we have one chat. Let's read that chat. Okay. Why did you pick moment at point A? Good question. I really, this is something good because why? That's a good question. Because usually this is kind of a way I have two unknowns. One is called A, another one is called B. So either I take the moment about A or about B, or I could take the moment about point 9, this point, but I will end up with solving two simultaneous equations with two unknowns equations. So the best way, either I take it. So let's try to take the moment, repeat this step, to take the moment around point, and instead of A, we take it around B to see what's the difference. So I would just change the name for this one. And again, I assume this is always the same direction for me. So let's try this. So at least to show you the difference. All right. So now I'm taking the moment around point B. So B should be not written in that question, and everything is clockwise. So A is rotating clockwise, so it will be A times what? The distance 4 plus 2, which is 6. Right? Now, what do we have? We have the 9 kilonewtons. Which direction the 9 kilonewtons will be rotating? Will be rotating negative, minus 9 times the value is 2, because it's rotating this in that way, which is counterclockwise. To rotate that at point, which point B is fixed, is equal to 0. Now you say, hey, why you didn't take this force? Because remember, this force will pass through that point, and therefore no moment for this force. And that's why we say from first step, this force is kind of, we don't need to consider it at this stage for this example. So after we determine that, now you just need to rearrange the equation and to find the value for A. So A is equal to what? And 9 times 2 divided by 6. And if you find the value for A, as you see it, we found it obviously earlier, is equal to 3 kilonewtons. So I hope that makes sense to you, because we found the value of A earlier. So let's write this, at least to make sure you guys see it very clearly. So this is, I will call it OR. So let's bring this here so we don't confuse you. And we have another box here to say OR. So in case you want to take the moment around another point. So OR, another method. So you don't need to do both. One of them is more than enough. And that's what we need to find. If you have any question, please, I'm checking the chat. So if you have anything to go and you want me to try something, try this question in a different way, just let me know. Does that answer your question? If you're okay, just comment. And since I'm not displaying the comments, you will not see it. No one can see it. So why can use a right? So we can use yeah, of course. Yeah, you can use any one of them. So any one of them. We don't have any issues. It's just I always try to use this point, but you definitely you can choose which one. So Ninant, good. I like lemon squeezy. Can we do one with a UDL? Yes, I like to have a one with a UDL. I do it. So what I have today for you guys, I prepared. Let's show you what I have today. I have this question for you guys is from the lecture notes as a cantilever with all many different loads, but I have something more exciting, a cantilever with UDL. So that's also something. So which one do you prefer? If you write on your chat 1 or 2. So 1 is this one we start, or we do 2. You have the option to choose. So if you go to the chat, put 1 or 2. As soon as I see more for going one of them, I will go to the most one. Okay, 2. I see more now for 2. 2, yeah. We start with 2. Looks like 2 is going more popular. All right. Okay, 2. Yeah, 2 sounds more interesting because it's a cantilever plus it's a UDL in it, which is something good to experience. All right. So let's start with this question. Sketch a shear force diagram and bending moment diagram for the following beam. Hey, muted, please. All right. Someone is adding the voice. I can hear my voice as a feedback, or it's coming backwards to me. All right, so again, what we were doing, we will apply. Just let me first to copy those main equations because I technically need them. Will save my time when I solve this question, because I don't need to use the equation editor again and again. It's easy to copy them and work on them. And so I'm just using them here. And again, that's maybe another reason why I use always A, because I copy the equation and already was set up at A. That's maybe the reason, but we can change it anytime. So this is a cantilever, which means one end is fixed. We need always to write this, just showing you this end is fixed. And the other one is free. So this end is free. All right. So 2 ends, one is free and one is fixed. My recommendation for you guys always in this kind of questions, start always when you draw the shear force and bending moment diagrams from the free end. All right, I will just copy this question again, so at least we can use this space for it. So first of all, we need to sketch the free body diagram. So I will give you maybe 1 minute, try to sketch a free body diagram, and then we compare all together. All right? So take a minute. And then what I would do, if you have your camera on, I want you to show me your free body diagram. Just put like a page like this and say, hey, this is my free body diagram. All right? So I can see how you're doing. If you don't have a camera, don't worry. We can find it later. We can show it later. All right? So just 1 minute till we do it all together. So the guys who they haven't got the headphones, please next time try to bring your headphones, because I don't want to hear my noise as a back. If you don't have a headphones, so they can go just around one of the rooms, and then you can open the speaker. I think because the time is about 3:43, so many classrooms should be free. If you can zoom in, because I can't see it. Yes, that looks good. Now, the moment you choose is kind of different from what I choose. Always try to understand how this moment here will lift. If all the loads are going downwards in that direction, so you need a moment to be opposite to these forces. So kind of counter, kind of clockwise moment. All right. Okay, let's do it together. I think now we may do it. So you just sketch again the beam. You can simply allocate the forces which we have and originally from the question. So let's say there is a force about this distance here. The value of this force, don't know, come on, this box. And the value is 4 kilonewtons. Units are very important for us. And just take this away from here. It's not interfering with me. And as well, we have a 3 kilonewtons. Don't forget that. So for saving time, Control C, Control V. And then I have about here 3 kilonewtons. And as well, I can say about that distance in the middle, I have what's the UDL. So UDL, how can I do it? I would just show it in that way. It's exactly the center where is the 3 kilonewtons located. So right here, so let's say this is if we write the equation, 1 kilonewton times the distance from 0 to 4 is 4, which is equal to 4 kilonewtons. So this is actually the UDL. I'll write UDL, so at least you understand this is a UDL value. All right? Now, what's missing in this? I haven't done yet my support reaction. So which direction support reactions is coming from the beam? So I will assume one is going upwards in that direction. I'll mute this one. And so, so support reaction is going in that direction. Just want to do this if I can move them on the side. No, it's not moving. Okay. So, and then there is a moment in that direction. So that's what we have. So support reaction and a moment in that direction. So which one is wrong number? Didn't get it. So can you give me more information about the wrong number? Because I'm seeing wrong number. Wrong number for UDL. Why do you think it's wrong number for UDL? Because UDL, we are locating it in the center. So it's 1 kilonewtons per meter times the distance 4 meters. So what's supposed to be? Oh, no. I know it's confusing, but because it's here in the diagram, if you can see it carefully, it's UDL is covering from 0 to 4, and that's distance we read for us. It's 4 kilonewtons. So it's good to go through this now. We want to avoid this kind of common mistakes in the exam. UDL again, I didn't really get it. Okay, I will go on through the UDL since it started confusing you guys. So remember, first, this is the UDL. It's covering from 0 to 4. So it's four, let's say 4 meters. How do I know meters? Because you see the length, the total length is 10 meters. So the value of UDL in that green here, I will zoom so you can see exactly what I'm talking about. So this one is 1 kilonewtons per meter, right? So that's is the UDL value. That will be located here, and that will give you the value of 1 times 4. The distance will be 4 kilonewtons. So that's the UDL. Now, on top of that, we have 3 kilonewtons. Did happen on top of that. Because this question wants to test us how can we deal when you have a UDL and a force at that position, right? Okay, I'm just putting my point A here so I know what we're doing. Now, to solve this question, I'll go through the comments very soon after I finish the second step. So now after free body diagram, we need to find summation forces in the y direction. Already we have the vertical. So what do we have in this equation? Very easy. A is equal to what? A is the only one is going up. Against A, how many forces? You have 4 plus 3 plus 4. So 4 here kilonewtons, 3 kilonewtons is a point load, and you have the UDL, which is the 4 kilonewtons. And that will be equal to what? Equals to 11 kilonewton. That's very easy. That's the value of the support reaction at the point A. All right? Now, let's see the chats. Do we add force 3 kilonewtons and the UDL? No, I prefer you separate them because you will confuse yourself. So don't add them together. Don't. Because if you may add them, you will not get the effects of UDL on the shear force diagram. Remember, when UDL always will get a slope, and the point load will get a vertical line. So if you add them, how do you distinguish that? So I will avoid adding them. Now, we take a moment about point A. And from that moment, we try to find whatever is the impact of the force or the moment here, which we call it moment A. All right, so please pay attention here. It's very, very important. This here, we call it moment A. So cantilever, one of the rules of cantilever provides me with moment A. And that's something we need to be aware of when we're trying to gauge the shear force or free body diagram. There is always moment A we're trying to determine. So that's here is a moment A. So the first thing we start with it, because I assumed Control-C, Control-V, this is my positive direction of the moment. So it would be positive MA. Just copy this one to make sure I get it. All right, what do you have? Minus. Now, why minus? Because if you see the 4 kilonewton will rotate counterclockwise. So 4 times the distance from 4 to MA, if you see from 7 to 10, is 3 meters. So times 3. Now, again, you have 3 kilonewtons. So that's again another point load. So it will be minus because we'll rotate the beam in that direction. And that's MA will try to prevent that rotation. Otherwise, we'll confuse or we'll collapse the system. So again, we have 3, the point load, times what? The distance. So from 3 to MA or that point. So what do you have from this 2 to 10? So technically 10 minus 2 is equal 8 meters. And then you have the UDL, which is also negative, minus the UDL is 4 kilonewtons times the distance. UDL is at the center, so it should be 8 as well. It's just as we say, it's happened at the same location of that point, is equal to 0. You solve this, you find the value of MA, the moment to prevent, for me, this UDL load and the 3 kilonewtons and the 4 kilonewtons from pushing the cantilever down. I need a moment about 68 kilonewtons meters to prevent that motion. So imagine if that moment didn't exist, then that's free end. Remember, this is the free end. This free end will be will not be supported. Therefore, the fixed support here is applying me a force in the vertical direction. There was another question I see from the chat. It's saying, how about the horizontal force in this example? No, if you see, there is no horizontal force in this example. Therefore, the wall at this stage is not providing any support in the horizontal direction. It's only providing vertical and moment. But if there was a force in the horizontal direction, yes, I should have a force opposite to that equal in the magnitude. So that's why I'm not putting the force in the horizontal direction. So after we found the support reaction, which is the value of A, I'll write it here so we can highlight the values we determine. A is equal 11 kilonewtons. So you guys can write now on the chat any questions before I move to the next step. Any question you have so far we're done, so I can answer them now. So I'm going to the chat and see if you have any questions. Any questions so far? Okay. Isn't there a horizontal force as well in the point A? Yes, it should be, but because we don't have a force against that force, therefore I didn't put it. The moment for point A, did you take the clockwise or anti-clockwise? Good question, because since I put this sign, I think I put it in the wrong direction. This one is represent for me clockwise, so that's the moment at A is clockwise. Yeah, good question. That's really good one, because otherwise I missed it. Now, if ask support reaction at A would end be 68. Yes, you have two support reactions. So you have a force support reaction, which is 11 kilonewton, and you have a moment support reaction, which is 68 kilonewtons meters. So that's the difference in the wording. We can say just in general support reaction, or we need to specify them because one is a force and the other one is a moment. The moment is a support because without the moment, the UDL and the point loads will push the free end down, and then you find it's kind of is bending. So it's like this is the cantilever, and if you have more load, what will happen to it? It will start bend in that direction. But the moment is trying to prevent it from bending to keep it in that horizontal shape and with no issues. All right, any other questions? Yes, I answered that. So if support reaction is 11 kilonewtons, that's a support force reaction. So we must say force reaction. So if it's a force, it's 11 kilonewtons. If just support reactions, then we have a moment and a force. Any more questions, or do we move to the shear force diagram? All right, I can't see any more questions, so I'll come back to the chat and after we finish the shear force diagram. So as we land, what we do always, I projected all the most important lines. So here is the free end, here is where is the middle of the UDL, here is the end of the UDL, here is where the 4 kilonewtons, and here is the end, which is the fixed support. So always it's to make our life easy, honestly. That's the purpose of it. I will have a line here using actually, what I can do, instead of that, I can use this scale, and I will call it shear force. Now you say, hey, why are you doing it like this? Okay, I will answer you now. Usually, in fixed support, since the direction all of these forces are going downwards, therefore you find that's your shear force diagram giving you values all in the negative, and that's why I'm using it that way. So you see, this free end, there is no forces pushing it up. Therefore, when I'm starting from this 0 point, everything will be going downwards, and that's why we'll see it very soon. So please pay attention here. This is very, very, very important. So if I take this section, I need to take a section to a point so I can show you. I will take section till that point. That section is exactly just before the 3 kilonewtons point load. And then I will put the section, just free body diagram here again, a line, straight line, and I'll bring that section, Control C, Control V, and oh, that's something. It's good we have Control Z. And that's the section. And now what you have a UDL only. So what I'm showing here, I have only UDL. The UDL is pointed downwards. So what's the UDL? Where did I cut it? If you look carefully, the distance I cut the section, can you write it in the comments? What's the distance for my section? So I'm checking now your comments. If you can write me what's the section distance. Can you write in the comments what's the distance for my section? So I took a section just at that point. So what should be that distance? Okay, I start getting numbers. I want to know more. If you guys can go to the chat. 2 by itself is not acceptable, so you always need to say the units. So 2 meters sounds good. 2 is also acceptable, but next time please put units. So yes, correct, 2 meters. So that's the section. Now my UDL here, I don't have any external load at that point. It's free end and UDL to that point. So my UDL, I would just copy this equation. So it would be UDL is equal what? 1 kilonewton times the distance. Now I'm using only 2. 2 times 1 is 2 kilonewton. So that's how we do it for that section. So it's mean because it's UDL, I need to use a curve. So since we are using PowerPoint, so I should get a curve like this. Hopefully I can make it. Oh, yeah, slightly cool. And then I write the scale here to just show the line that this point represent for me. Oh. So here I'll just write in a box to say this is the value of 2. But why it's -2 is in the negative, because we have a force going only in the negative direction. All right. Now if we go to the next part of this section, I need to take another section and to be, for example, at 4. So let's remove that section we took already, because I already transfer it here and I'm showing it here. Now we take another section. So every time where is a line, I'm taking a section so I can address the points here. So let's say this section will be here. So Control C, Control V, and that section, we'll say that section is here. And I need to put the points we have. We have a load. So let's say this is the load, and that load is pointed here. So from that section, logically, should be longer than the 2 because it's 4 meters. So I'm making it like double. I will take this dimension so I can show you how we do it, and then we move it here. Now, see, if that was 2 meters, I need to just expand this to make it looks like more reasonably as a 4 meters. And I will change this value to be 4. Because now I took a section longer than the last one. And as well, remember, we have 2 loads. So one is here, which has the value of 3 kilonewtons. 3 kilonewtons. And there is also, underneath that, is the other load, which is the UDL, which we found it earlier. So that's exactly what we got in earlier. So we technically covered everything till that point, which is the 4 meters. We have 3 kilonewtons point load, and we have a UDL here. This will help me to determine the values of there. So now how we determine that? So what you have 2 loads, and we need to find opposite to that is a support reaction going in that direction. See, for the previous example, no one asked me how did I get that 2 there. I know you saw it, but actually you can prove it by sketching the diagram here. Oh, my arrows sometimes are really funny. Let's try to get the better arrow than this one. So this is the shear force we're trying to find at that point. So what do you have? Let's call this shear force just V, just for simplicity. V. So that's shear force V. And similar to here, we found the shear force V. So what was missing in that previous free body diagram is to put that V as part of it. So we should have something here to determine. So V is its opposite direction of this value, and that's why we get the value of -2. Now here, what's the V? A summation of forces in the y direction. What do you have? You have the 3 kilonewtons going downwards and the 4 kilonewtons going downwards. So adding these together, V is equal to what? Will be equal to minus, or in a way, -7 kilonewtons, right? Because you have two loads going downwards and then one going. Is this correct? But one thing I need to take into consideration, at that point I have a 3 kilonewtons going downwards. So therefore, if I took the moment, as one of you asked why I don't work with the UDL straightforward, then I will miss this point, because I should have a load going straight forward in that direction, which has the value of -2, -3, the answer for that will be, and because it's going down, so I write it, -2 minus 3 is equal -5. That's the point we're trying to find. So I'm moving with UDL, because there is a point loads going downwards, we'll push it about -5, and now from that -5, I have another one, which we found V was taking me to -7. So from this point, I need to have another load, which should be as a curve, because it's a UDL. So I would choose this one. So it should be something tinier than this. Something like this will be going in that direction. I'll answer your questions after I finish this answer. So that's also in a curve going in that direction. So now you have -2 minus, and that value is -7. Now you say, how did you find the -7? I already showed to you when we found the cross-sectional at that point. V is equal -7. So V represents shear force value. Now from -7 till 7 meters, I have no load on that system. So I will move a straight line I'm not getting my straight lines. I'll move to -7. Now from -7, what do I have? I got another -4 will push me down. So I will get another load is taking me downwards, which value will be added. I'll write how it works. So it will be -7 -4, and that's equal -11. So that's a new point here. It's -11. I will highlight this to be darker color, so at least you can see what we're doing. By the way, those curves, they should be really improved better. They should be smoother and nicer, but because of that. Now, one thing, again, I'm done a mistake and no one is correcting me, which I need to fix it now. I'll tell you very soon. I confused myself. So again, no load going in that direction. And then that's his -7. What was the support reaction is equal to 11, sorry, -11, and that's is equal 11. And then I go to that direction to close the diagram. Now, one thing is happened here, which I was mistaken in it. I didn't fix it. This actually, they should not be curves. They should be a slope or gradient. So this one should be changed, delete. So those only curves if you're sketching the bending moment diagram. Since we are not sketching the bending moment diagram, we're sketching the shear force diagram, so there will be always a gradient going downwards. I don't know, we'll go and check the chat and see how many of you try to remind me how to fix this one. Let's see how many of you managed to remember this. I'll go by the time, okay? So not mean after I found that out. So that how it should be, the the shear force diagram. So again, please just correct this. This should be, because we're drawing the shear force diagram, this values should be all correct except the shape. It should be converted to a slope or gradient going downwards. So let's see the comments now. I presume there are 3 comments. Why is a curve? Yeah, okay, I got one is saying why a curve, which was about 3 minutes ago. And I thought curve is for bending moment. You're right. And bending moment, you're right. So now all of you try and getting it. Thank you. But I didn't see anyone before that time to someone correct me. Why is it a minus? And I didn't get it, how you got the V and how is it 7 kilonewton. Okay, so I'll go through this again to make sure you guys all got it. So one mistake I have done here, guys, which I figured out and then I corrected. So when we sketch shear force diagrams for UDLs, always are slopes. But when we sketch the bending moment diagrams, they will be converted to curves. So in this case, we need to find the values of them. So let me revise step by step. First of all, we sketch the free body diagram. We replace the fixed support by support reaction vertically A and a bending moment MA. Now this bending moment will prevent the beam to bend on that direction. Now what do we have? Remember that UDL, it's 1 kilonewton per meter, so the distance is 4 meters, so I multiply by 4. We use the support reaction. If you're wondering which direction was the support reaction, so it's going upwards is the positive, to make sure we're using a positive support reaction. We found the value for A is equal to 11 kilonewtons. We took the moment about point A, which is clockwise is positive, is equal to 0. So MA minus 4 kilonewtons times the distance 3, minus 3, the point load times 8, that's distance, and minus the UDL times 8, and then rearranging this, we find the moment is equal to 68. All right, so this all should be fine. Just let me get you space and we go through it. Now, to sketch the shear force diagram, we needed most important information for it. We needed just the support reaction at point A, which is the 11 kilonewtons. So always for cantilevers, guys, please, for cantilevers, we work from the free end. This is the free end and this is the fixed end. So we work from the free end. From the free end, I will highlight it, so make sure when you guys work on this kind of questions, you remember where you're working with. So we start from the 0. There is only a section I need to take. So I took a section at 2 meters before the 3 kilonewtons. So the 3 kilonewton will be cancelled. So what you have a UDL supported by 2 kilonewtons. So let's say it, if I zoom in, print screen, I'll show you how can I do it in better details. I'm working on it on different zoom. I'll share it with you now. Let's see. Okay, share. So I'm sharing with you guys this paint. So what's happening in this paint zoom? What do we have in the paint zoom? So kind of, I took a section at this point. So that means this section, all of it will go. Let me take it. It's a bit my mouse slow. This section is gone. Okay, so I'm just taking it. So we kind of only considering this section, but one thing we need to remove is the 3. So the 3 is not part of the section. We have only the UDL and we know the distance. So what you have in that section, if we take it and bring it to the PowerPoint slide, I will share it with you guys very soon. Okay, share. So now I brought it to the PowerPoint. So remember, so I cut that section, I brought it here. That's about 2 meters. So I'll put my dimension to make sure you guys know what I'm doing. So this distance is 2 meters. We write the dimensions, we make sure like everything is okay, 2 meters. Delete, we don't need this. So now, what do I have? I need to transfer the UDL to what's a point load. So UDL will be in the middle. What's the value of the UDL? It's 1 kilonewton. So it will be 1 times 2 is equal to 2 kilonewtons. Now, where is my shear force? I should have a shear force going in that direction, upwards. What we call that shear force is equal to V. So, what we learn when we solve this kind of questions, we always need to find the summation of forces in vertical axis. So, forces in the vertical axis is equal to 0. So, what we have here in this equation, we have 2 kilonewtons, let's say minus 2 plus V is equal to 0. This with assuming that positive is it's the upwards is the positive direction. So if you can tell me what's the value now for V, V is equal to what? If you rearrange this equation, V should be equal to 2 kilonewton, right? Now, but remember, this is the action internally. It's not the whatever you're getting in the support for this direction. So if that's 2 kilonewtons is here, it means because it's a point load, the cantilever always you treat it differently. All the loads are going on downwards, and then you find the answer for them. So do you know this one or not? Let's see what's in the chat. I mean, y is V and y is 1.2. Okay, y is 1.2. Reason because why of 1.2? Because when I cut the section, I know every 1 meter it's equal to 1 kilonewton. Every 1 meter is 1 kilonewton. So I have 2 meters. What should be the UDL, Michael? Since you're looking, you can type. Why are you putting question mark? Should be 2. Because 1 times 2 is equal to. So let's go through the UDL, since it's really very important. Since the UDL is confusing you guys, I will go through it now in steps. So let's take this, because UDL may be one of the things required more attention. I'm preparing a new thing, so I'll go through it and I'll show you exactly what I'm talking about. All right. Let's share this. Preparing with you guys. Where is it? Where is it? Yeah, share. So this is the question. I go back again. Okay. Now, this distance, if 1 second. Again. Just 1 second, because I'm changing from a screen to another screen. So, okay, this is the question. So I got it here, so no problem. We know the distance here. This is a question for you guys. The distance from this end to that end is 4 meters. We type 4 meters. Now we know what the UDL, it's every meter. So when they write this expression, I didn't need this. So when they say UDL is equal 1 kilonewtons per meter, what means every 1 meter UDL equals to 1 kilonewton. So if I have 0.5 meter, what is the UDL value? Try to find now. Can you put this on the chat? So answer this question using the chat. All right. Yeah, correct. Yeah. Perfect. So there is always a correlation between the length of the beam and the weight of the beam. So always we're trying to do it. So now, if, let's do it then again. If the length is 3 meters, or let's say 3.5, what is the weight? Try now. Michael, where's your answer? I can't, yeah. Michael, your answer? Cool. So 3.5 kilonewtons. And we remove the meters because we're finding the weight at the center of that. So every part. So now let's make it more interesting. What about if it was 0.2 meters? What is the weight? Oh, Thais is here. Good. Nice to see you. Are you in the room? What's the answer? I'm getting just few answers. So UDL. So is UDL the same weight? UDL, it's a term uniform distributed load. Weight is the centroid as the center. So one is the weight, where is the point load at the centroid. The other one is uniform distributed load. So every meter, every 0.1 meters. So the answer is 0.2 kilonewtons or 200 newtons. Okay? Is it clear now? Good. That's perfect. So let's go back to the question. So since we took the shear force, so every time you can take a section to find the value of the weight. So maybe here, to stop confusing you, we can write weight, W, and that's why we'll stop confusing you. Make sense? Okay. And then you determine the values, you find the shear force. So that's exactly for finding the shear force. Can we repeat the same steps to define the value for the bending moment, or the diagram for bending moments? Okay, there's a question. Why is there a -7? Okay, the -7, because what you have 3 and 4. So adding these together will be summation of forces in the y direction. So that will be, I will use this equation. So what will be 4 plus 3 minus v is equal to 0. Then v is equal to 7 kilonewtons. But because it's downward load, so that's why it's going to be a negative. Is this better now? How we got the -7? Let's see, more chat. Why is there can you explain it? So is it clear now? Because I did write the equation for it. So that's the explanation for it. So you take summation of forces, you have the 3 kilonewtons plus the 4 kilonewtons, and opposite to that will be, okay, and then you need to see me after the class, maybe. All right, so let's continue with this question. So what do we have? It's now Negative because the load is going downwards. Always we have a negative because the load is going downwards. If you see the direction of the arrows, always they are going downwards. That's why we're having a negative answer. So when the arrow is going downwards, we should have always negative forces. We can't put it upwards. So that's the reason we're getting negative, all right? Now, the bending moment diagram for this question. So we can work it by areas. So because I need space here, so I will take this one. So what I would do, I would take a print screen for this page, and then I can copy it to another one to show you exactly how can I sketch the bending moment diagram. Right, let's bring it here. That's easier. So this was the shear force. Now let's use the scale to sketch the bending moment diagram. Bending moment and units kilonewtons times meters. All right. So here on the side is the shear force diagram, and I will use based on that information to find the bending moment diagram. What we learn, we work always by area. So let's find the first area. The first area here, what is the first area? So I'll write the area for that part. So you have half of the base, I'll call it A1. So we say Control C, Control V. So this is area 1. Let's try to determine area 1. So half of the base, but what's direction is negative. So negative, half of the base. What's the base? The distance is 2 meters. So 2, I'll say 0.5, which is the half, times 2. What's the height? It's 2. Now, if you ask me where I got the negative from, because I already have a negative here is -2. That's why I got the negative, because it's a negative area. So therefore, when I sketch it in the bending moment diagram, it will give me a negative answer. So that would be exactly. So 4 divided by 2, the answer is 4 kilonewtons meters. All right. So I will sketch, as we say, when is a slope in the shear force diagram, it should go as a curve. So I will sketch a curve here. I'll finish the shear force diagram and then explain the topics one by one. So this one will represent for me, put the value because we have the units already set, so I don't need to put the units again. It's -2. Now, from that point, we need to find the area for the second part. So if this was A, Control C, Control V, area 2, and area 2 is subdivided to 2 areas. So how can I find area 2? Here, what you have a triangular at that point and a rectangular. So this is a triangular and this is rectangular. This rectangular has a length or height of -5 and the length is 2 meters. And this one, the height is -7 and +5, which is 2, times half of the base, which is 2. So let's write it for the second area. So let's call this one A2, so not confusing ourselves. And let's determine the area 2. Area 2 will be equal to what? It's also negative. I'll put the negative in advance, so not confusing myself. Will be 5 times what? Times 2. That's for the first part, the rectangular. And then let's use another brackets type, so we distinguish them, plus. Now what do I have? Open brackets, half of the base, times the height, which is 2, times the length, which is 2. Close the brackets. I'll bring the equation here so you can see what exactly we've done. So that's the first 5 times 2 represent the rectangular area. The other one, this one, is the small tiny triangular. It's half of the base times the height. How you get the 2? Because 7 minus 5 is 2, the height, and the base is 2 meters, from 2 to 4. 4 minus 2 is equal to 2. What should be the area? Can you write me the answer? It's equal to minus 14 kilonewtons meters. So again, I need to find another curve, Control C, Control V, something similar to that, and we find the value. It should be smoother than that, but I don't have something to make it smoother. but I'll show you later how can I adjust it later when I have time. I'll show you how can I replace those smooth curves with something better quality. Now, since we've done this, now what we have is to find the area for this one. So let's call it area 3. Area 3 is straightforward. Area 3 is only rectangular. So minus 7 times 7 minus 3. So the area 3 is equal minus 7 times the distance from 7 to 4 is equal to what? 3. And that will give you an answer of what? So can you find me the area for this one? I think we got something here. It should be 12. I don't know if how many of you corrected this to me. Area 2 is 12. Yes, you're right, Binder. Yes, you're right. I agree with Matthew. So what's Matthew? Yeah, area 1 should be 2 and area 2 should be 12. Yes, you're right. You're right, Matthew. I just got it wrong. That's why I was looking for someone to find the answer for it. So area 2 is 12, and that's why we add. So minus 2 minus 12 will give us the minus 14 as adding them together. Can you find me the area 3 is equal to what? Area 3, it's minus 21. And then when you add minus 21, yes, and then you add them, and the way will be a slope line going in that direction. But what will be minus 14 minus 21. That will be equal to minus 35. So that's the point we're trying to get here. I'll just connect this line here, so at least we yeah. Cool, guys. I'm sorry, Mohammed. I need to leave for work. Okay, no worries. Hopefully this will be recorded and then you guys can watch it anytime. All right. By the way, guys, don't leave because as soon as I finish, I'll come and see you in the class. All right, so this is where the minus 35. Now let's try to find area 4. Please, if something wrong, just try to stop me so I can correct it because now I'm too many things around me. All right, so area 4. How can we determine area 4? Is again very straightforward. Area 4 is equal to what? Is equal to minus 11 times the distance 3, which will give us minus 33 kilonewtons meters. Now, again, that will be from that point going to this point, which will be, if we write the equation very carefully, so minus 35 minus 33, the answer is minus 68. So at that point, 68. Now, guys, I have a question for you. I reached to this point and it's minus 68. It's not closing, so what do I do? I'm confused now. Any idea? So what, are we missing something? Or there is a way to close this diagram? Yes, perfect, perfect. We have a moment, which is, I think is supposed to be. So we have a moment. Remember what we did in the last thing? We found the moment at A is equal 68 kilonewtons meters. So that moment will help us to have a line and to close this in that direction. So that will close it till here to that point, and that's the moment which we need to address. Therefore, this diagram closed. Now, these lines, I'm not really happy about them, those curves, so I need to change them with something more better. So what I can do, I can extend this in that way, and then will be a bit slightly represented in this way, because they're really not what I want to see. And then as soon as I finish this line, I will open the questions. I will answer your questions. All right. It's not working, this line. Yeah, cool. So technically, your will be similar to this one, and that's the 2 will be somewhere here, and the 14 here looks more reasonable now with the numbers is going higher. So Michael was you asking, I think it's supposed to be 2, not 12. Which one? Sorry, Mohammed, I already left the class. I have been watching this from my home. Oh, okay. Someone left the class and already watching from home. That's good. So if you want to send me a private message, I will not say your name. I'm just reading it. Anyway, so it's good, guys, to see you now attending. So after this, I will come to the classroom to see what you have done, and we can revise any question you have. So I will go now to questions. Let me first to stop recording and save it.